Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I appreciate you watching. Thank you for joining me today. So we're wrapping up Module 8. I believe it is about our list data structure. And we're moving on into the next module, which is about files. Or we've done lists, we've done dictionaries. Those are our two big data structures that we've done. And now we're moving on into files. And using files to do input and output from a program. And so your dictionaries module is due today, right? Don't forget that as we're getting started here. But I think you'll find that the dictionaries module and this module on files, and really on back to the module on lists as well, our lists, dictionaries, and files modules kind of dovetail pretty nicely into one another, because at the end of talking about dictionaries last time, right, we made an important note about dictionaries and using dictionaries. And we've seen this time and time again in programs that we've written throughout the semester up until this point. Right? It's that we have data that we put into a program, and we're able to run a process on it and execute it and get a result back out. But once that result comes back out and our program stops, then it's forgotten everything about everything that we've done. Right? It's taken and just put that out of mind. If we run the program again, it won't remember anything that we did before. And for the vast majority of programs that we've worked on throughout the semester, that's okay, right? That's just fine. But for programs in the real world, that's less than desirable, right? Like, we want our programs to be able to remember and recall data that it's used in the past, to be able to bolster our programs and have important, valuable information for us. And so that's where the concept of using files come in. And we're using files here in relation to into being able to store that data for a long time. Other applications might be, databases might be a way that we would use this type of storage. But for this class, since it is an introductory class, we just focus on simple file use. And you'll see that the two different types of files that we're going to be using, text files and CSV files, relate to databases. For those of you who've had a little bit of database knowledge behind you, they relate to databases in different ways. The CSV file is more like what we would understand to be a database, right? Even though it's a flat file database instead of a relational or a hierarchical or / non-relational database. It is also similar to the dictionary that we were talking about in the last module. Right? Because typically in like a database, for example, we have some sort of key and some sort of value for that key. And we're able to look up different records for different users based on the keys and values that we have. Right? Which kind of sounds like dictionaries. And when we're talking about text files, which is what we're going to start talking about today, I mean, one of the things that we do with text files is that we take them and we load them up and we work on them, and sometimes we might load them into a list or array to be able to do our work on them. Right, and so that's how these last several modules all kind of mesh into one another. But as I'm getting started talking about files today, I really want to get started talking about files in a really simple context. And that is, first, just what is a file? And asking the question of what is a file, it kind of sounds ridiculous, right? Like we're all IT people. You're in an IT degree program. You'd think, in terms of computers and digital files, you'd think you'd have an understanding of what a file is. But as per usual, I like to provide us with a more formal definition of what a file is and what is important about a file in our context. And really what I have here is crucial to understand about files as we're working with them, because it gives us this sort of hint as to how things work. Right? So our simple definition of a file is that it is a named location on disk to store related information. Right? So I have a file that's like, myessay.docx, and it's a Word document file that has my essay in it for my class, or just whatever you've got, right? So when you have a file, this denotes two things about a file that's incredibly important. One, that it's located on the disk, right? It's stored on the hard disk. And two, and really I guess there's three things here that are important. Two, that it's named. And three is that everything in that file is related. Right? Everything in that singular file has one purpose. And if you have multiple purposes for data in a particular application, you might need to use multiple files. Right? So just that one formal definition there gives us three actually good insights into how we use files and what it means to be a file. And one of the first things that I said was that the file is stored on the hard drive. It's stored on the hard disk, stored on physical memory. And that gets us into this idea of volatile versus non-volatile memory. Let's go down a little rabbit hole here for a second and talk about the idea of how a computer works and how the data cycle works. And again, this is going to provide us with some insight in terms of how we use files and what we should do with files. Right? And so I think we talked about the general concept of a data cycle early on in the semester. And it's IPO. And when we're talking about IPO here, we're not talking about initial public offering, right? It's not a finance class or a business class. It's a programming class. So when we're talking about IPO here, we're talking about input, process, output. Right? Data enters my computer through some input means, right? Whether it's a sensor, whether it's a keyboard user input, or whether it's a file. It is run through a process, and after that process, our data has been transformed into information, and it's now our output. And so our input and output, we kind of have a good understanding of these two items. But our process characteristic here, our process characteristics doing a lot of heavy lifting. right? Because when we think about what's going on during the process, and I'll even simplify it more here, like, we could get into the weeds with like computer engineering and talk about like, oh, the backside bus does this, and the processor has these 3 different phases that it carries it through, and so on and so forth. But we won't worry about that. Right? We can break down this process into some simple ways. One is that it involves our hard drive. So we have our hard drive here, and our hard drive has data stored on it. Two, it involves our RAM. And 3, it involves our processor. Right, so we have our hard drive, we have our RAM, we have our processor, our CPU. All right, let's go ahead and label these parts so we can have this understanding here. This is our RAM. This is our CPU. Now, we said files, in general, files live here. They live on the hard drive, so we can consider this to be the home of our files. It's where our files live. They have some sort of address location on our hard drive. Now, when we want to use a file, or when we want to use data in general, we can't just work with the data that's on the hard drive. Right? That's in, we can kind of think about that as cold storage, as inactive storage. So before we can actually do things with our data, we have to take our data, pass it from our hard drive, and store it temporarily in RAM. Right, so it's lying dormant on our hard drive, and we bring it and we store it temporarily in RAM. And for larger applications, this could happen in chunks. Right, it's not something that we worry about at this level for programming. Is things like memory threading and dealing with memory in general, and having to worry about like when we have to load different parts of our program and all that kind of stuff. Right, so this is the time where we kind of talk about memory, but we talk about it in a very general, overall, abstract sort of way. Now, our RAM has another name. The other name for RAM is volatile. Memory. RAM is volatile memory. That's volatile memory. And A. I'm sitting there writing it wrong and looking at it like I know that's wrong. Volatile memory. It's volatile memory. And that's where we've been dealing with most of our programs up until this point, right? Is in volatile memory. In volatile memory, if the program stops running, if you lose power, if your computer crashes, anything in volatile memory goes away, right? Volatile memory is temporary. And if we lose connection or we lose power or we lose anything during the time when data is in volatile memory, we lose that data in volatile memory. The volatile memory, or RAM, is wiped clean. Our hard drive, then, is known as non-volatile memory, or persistent. Right? When you reboot your computer, it doesn't have anything that was in RAM in it anymore, but anything that was on the hard drive, it's still there. Right? Barring your hard drive, still good. So all of your files, they're stored on that hard drive. They're called up into the RAM as the data from those stored files are needed to run applications. And then your CPU calls up and sends back and calls up and sends back and calls up and sends back, just over and over and over again, data from the volatile memory as it's needed. And when the CPU basically says, and again, this is a very overly simplified version of this, when your CPU basically says, okay, I'm done with all this data, then we can write it back to the hard drive. Now, I want you to notice some things here, right? Like, I want you to notice all of the arrows we have over here between our volatile memory, between our RAM, and our CPU. There's a lot of communication, a lot of going back and forth there. We're doing a lot of work in volatile memory. But we're not doing so much work over here on our non-volatile memory side, right? We only have 2 arrows over here on this side. And so that should give you an indication of one of the big ways that we want to be able to deal with data in our programs. We want to be able to load our data into memory, load it into volatile memory, perform our actions on it while it's in volatile memory, and then when we're done with it, write it back to non-volatile memory. So that data is saved to a non-volatile source, so it won't go anywhere, so we'll be able to use it in the future. And that's how we're going to be writing our programs. We're going to be loading our file in, loading the data in that file to some sort of data structure that we've worked with previously, whether it's a dictionary or a list or a variable or something of that nature. And then we're basically just working with the data there, just like we would have worked with it since the beginning of the semester. And then when we're done with it, we just write it back to the file, and we're good. Right? That's the way that things sort of work here. So the big key out of all this is that idea that we're able to take something that was volatile and make it non-volatile. The key word that I use is persistence. Persistence. We are doing things persistently. Which is useful. Right? So let's start out with just talking about the basics of using a file in Python. Right, and we kind of went over the basics, in terms of the data cycle there, kind of gives us an idea of how we would do some of these things that we're referring to here. But the very first thing that we need to do when we're working with a file in Python is we need to open it up. Whether we want to read it, whether we want to perform actions on that data, whether we want to write to that file, we need to open that file up. Right, so if you're a little old school, you can kind of think about it as like going to a filing cabinet. Right, and getting a file folder out of a filing cabinet. Before you can do anything with the sheets inside of that folder, you have to go over to the filing cabinet, find the right file, get it out, and open it up. And once you have access to it, you can put new stuff in it, you can change the things that are in it, you can do whatever you want. But the first thing we always have to do is we always have to open the file. And then we can perform an operation on the file. Right? We can read the data off of it, manipulate that data, write it back, do whatever we want. And then when we're done, we close the file, put it back into the filing cabinet to where we can use it later. So let's start off talking about opening a file in Python. It's pretty simple. Right, Python has a built-in function called open that's used to open a file. This function returns a file object, and we can use to read or modify that file accordingly. Right, so what we see here is we see some variable. Right, in this case, they're saying f for file equals the results of the open function on a file called test.txt. So if we're in our current directory, this is what we'd be wanting to do in Replit, is to basically do this here with the current directory. But our example below that is the full path to the file. So if you're working with Python on your machine, full path to file. And we can open it in a specified mode as well. We would just add this as a parameter to our open function call here. We can open it in read mode with the parameter R, in write mode with the parameter W, and the append mode using the parameter A. So let's do it. All right, let's get into a Replit here. Let's start off by adding our shebang, hashbang, usr/bin/env python 3. And let's go ahead and add our if __ name is main. Go ahead and get those best practices out of the way here. And so what I want to be able to do is I want to be able to open up a file, read a file, work with a file. All right, so let's start out by talking about how we would read to a file, or read from a file. And let's generate lines of dummy text here. I'm just going to get a little dummy text generator site here on another monitor. Just so we can have some dummy text that we can use. And I'm going to click New File here in my Replit window. New file right there. And I'm going to create a file. I'm going to call it dummy.txt. for our dummy text. Right? And in here, I can paste my dummy text, and I can do whatever I want with it, right? Like right now, it's one line. So for our purposes, one of the things that I might want to do with it is break it up into multiple lines. Just by hitting enter between the lines, which is a key thing that you can do with your files. One of the important things that I like people to consider when they're dealing with files is that you can kind of determine the way your file works and the way that your data works, so that you can have an understanding of what you need to do when, right? Like it makes life a little easy on you if you're able to manage your data on the back end. And so now let's create a function here. We'll create a function called read a file. And we'll bring in fname as the file name here. And as we said, the first thing that we do is we open up the file. So we'll create a variable, we'll call it f, and we'll set that equal to open fname, which is the parameter of the file that we're bringing in. And we're going to open it in read mode. So that's an R. So now let's see what we can do with that, right? Let's go ahead, and I said that gives you an object. So let's go ahead and print that out. And we'll print F here. So now behind my main gate, I will invoke read a file and dummy.txt in quotes there as the file name that I'm passing to it. Actually, this R needs to be in quotes as well. Getting just a little bit ahead of myself there. So R needs to be in quotes. To put this in read mode, file name, we'll be able to read the file. And so if we print the value, we get the object. And it tells us we have a text wrapper. A text wrapper of a file named dummy.txt in read mode, mode R. All right, we'll zoom in there on that just so we can see that a little bit better. A text input-output wrapper has been created. That's an object in Python. It's done on this named file. It's done in read mode. And we have the standard encoding there. So now what I want to be able to do is I want to be able to read this file. And there are multiple ways that I can read this file. And these are all functions that are built into Python, just like the open function, right? I can dot read. Could be something that I might want to do. And so if I change that printf to printf.read parentheses, because read is a function, as we said. So whenever we're writing a function, we have to have our parentheses there. Let's see what we get there. There's our text. And it's all just kind of spit out there, right? So if we wanted to put this into a variable, let's say we call this f, or we'll just call it file data. File data equals f.read. Right, we could put that in a variable too, and that's just going to create a string variable with all of the text from our file in it. File data. I put ready. Read. That's just a string variable, right? Like if we ran type file data, it would show us that that is just a string variable of the text that is in the class string. That's just a string variable of the text that's pulled back from our file. And so this is just a variable, right? That's one of our data structures, variable. I said another thing that we could do is we could put this in a list or array. And that's why I prepped this data here to have multiple lines. Right? I went and made line breaks between the different lines. So there's another function that can go through and read the lines of my file and read up to the line break. So we can call this file lines equals f.read lines. And so if we were to print our file lines variable now, we have a empty array here. Now, why is this an empty array? What have we done here to kind of break this? Let's comment out this line. There we go. Yeah, something with that unused variable. Since we, yeah, that's what it was. Since we read before we read lines, it did something weird to our file there, yeah. And so if we comment out f.read there and we just read lines, we get our data formatted out here, and we see this data is formatted as various strings inside of a list or array, right? Like we can see that because we have square brackets here. And if I did if I printed the type of file lines, we'd see that that gets us class list, right? So this is a list. Now, one of the things that I see typically that might cause us some problems, which is why I occasionally do things in a bit of a different manner. If we use our read line functions, I want you to notice them. Right, there's our escape new line character at the end of every line. So if we wanted to actually do something with this data, we might want to do something to where we truncate those last two characters off of those lines. Alternatively, right, we could use something that we talked about earlier in the semester, which is our split function. So if I used split here, so f.read.split on the escape new line character, we know that dot split converts our string into a list or array. And we know that we can specify the character or characters that it splits on. We see that we have this escape new line here in this program or in this text file, every place where we hit the enter key between lines. And so if we print file data out now, We can see not only do we have an array here, but we have an array that does not have that escape new line character on the end of it. So these are two ways that we can get workable arrays out of a file. And if your file is all one line, maybe you can look at another character that you can split on, or maybe you can do something else with it, right? Like just something to think about. But also remember that you get to control how your data is formatted because you're in charge of it. It's your program. So now we have a list, right? We were able to take it out of the file and put it into a list. Which is pretty significant, right? Because now what can we do to that list? Well, we can do everything that we've talked about over the course of the last several weeks, right? We can iterate over the list. We can search for things in a list. We can sort a list. We can do list comprehensions, calculations, search for text. We can do whatever we want to do, because in this instance, what we've done is we've taken this out of persistent memory, out of persistent storage, put it into our RAM, right, into volatile memory, and we've run a process on it. And now it's sitting in volatile memory waiting on us to finish up and send it back. Right, so now let's do something to where we can add a line to this. Right, so let's add a new function. We'll call this add a line. And we'll go for fname here. And I'm doing this in different functions. One, because a specific function should have a specific purpose. So if we want one function that'll read a file, one function that will write to a file, we should want two different functions for that. But also to keep them separated for when you're looking at this file later on. Right, and so if I go in here, first thing I'm going to want to do is open my file. So f equals open fname. Remember that f and fname here are scoped to the function, right? So they're not going to get confused with fname and f here. So if I wanted to, do something else with it, I could, right? We've talked about using global variables and such in the past. We could bring some of those in, but we're not here. All of these are scoped locally to the functions. And we said there are two different types of writable functions that we're going to concern ourselves with. That is a W function and an A function. A write function and an append function. Now, if I have an append function, it's going to add things to the end of my file. If I have a write function, it's going to delete my file, delete all the contents in the file, and replace it with the contents that I have in local memory to write, or in volatile memory and in RAM to write to it. So in general, when we're here getting started, what I like for us to do is use W mode. right? Because we're loading everything into volatile memory. So it's easy for us to put everything into volatile memory and take everything back out of volatile memory. Now, we wouldn't necessarily have to do that if we were just wanting to add to a file, right? Like, if I brought this in A mode and then I added something like f dot write input, add a line, right? And I changed this to add a line. It's going to tell me to add a line. Here's a line to add to the file. I'm going to hit enter. And now if I go to my dummy.txt file here, what I should expect to see is a line. It's right there. Here's a line to add to the file. But we can see that it just kind of tacked it on to the end wherever the previous item stopped, right? Which isn't great for us. So what I would rather do is something like this, where I open it up in write mode. I'm going to copy this text for just a moment so I can paste it back in. But if I tried that in write mode, where I said f.write input, add a line, it's going to add a line. Here's a line to add. But when I go over here to my dummy.txt, that's going to be the only line that's in my file, right? Because it took everything else out of it and just put that line back in, because that's all I'm telling it to write to my file. What if I did something like this, and let me go ahead and paste the old text back in, right? So we can have all that text in. If I did something like this here that we did in our read file, where I'm being smart about it, and I am loading that file into memory, into our volatile memory, I can say file data equals f.read dot split on our escape new line character. I can do a while loop and say like while true. We can say like x equals input, enter line to add, or D for done. If x equals D, break. Else, we can just append whatever was added to file data. So file data dot append, file underscore data dot append x. And then when that's done, we just write the lines. So it would be f.write lines, file data. And so this is going to allow me to add multiple lines. It's going to keep all the lines that I have, right? Because I'm loading them into memory and putting them in an array or in a list. I am using this while loop here to just add a bunch of lines, as many lines as I want to add. Now, note that they're not written to the file until I get to here. Right? So if something happens that interrupts me in the middle of me doing this while true here, in the middle of me running this while loop, right? Let's do some examples first. Actually, I am getting ahead of myself here. Because what I would want to do is actually use this function to create a, what would be smarter would be to use this function to create a global file data. So let's do that. So file data equals an empty list. This is global file data. Global file data, and then file data. And then we can actually, we can f.close here. So now here, in our add line, getting ahead of myself, doing different things than the things that I wanted to do. Here in the add line, so all of this is doing, right? All our read file is doing now is taking our file, reading it out, splitting it into our file data list. So we have a list that contains all the lines of our file. We can run that function in here. So read file fname. Now we can open our function or our file in write mode. So f equals open fname dot or fname in write mode. And now we're good. So we're using our other function to read our data. It's going to close our file so we can open it back up when we get to here in write mode, right? So by the time it shows us enter line to add or D for done, it's already opened our file, created this global file data, put all the different lines from our file into that global file data. And now we can just add a bunch of lines here. Here's line 1. Here's line 2. Here's another line. Here's something else. Right, we could just go all day, but then when we get to D, it's going to break. And it's going to tell us done. And we didn't get anything on our output here. But if we look at dummy.txt here, oh, that's interesting. Oh, you know what? I didn't. I'm not using global. I'm not using global file data here. I think, or that's odd. Let's print this out and find out what's going on here. because that should be in my file data array. Okay, so it's in there. And so let's print file data every time we append something to the file. So let's print file data, right? Live troubleshooting. So let's add some data back to our file. Let's run. We can see everything in there. Here's a line to add. Okay, so that's working. Did I miss something? The only thing that I can see here that I'm not doing is I didn't add the global, but it's doing it anyway because it is at the class level. Okay, yeah, it did it that time. It just added everything as one thing instead of multiple lines because we took our escape new line character off. So another thing that we might want to do before we write this here would be to do a list comprehension, right? So we'd do file data new equals I plus escape new line for I in file data, little list comprehension. And now we can do file data new here. Right, this is also what happens when I don't have notes for the program I'm going to write and just end up writing it on the fly. So let's reset our data values back here. We'll go ahead and comment out this little print line here that we used for troubleshooting. Run this. We can see everything's there. Here's a new line. Done. Or D, rather, because that's what we said. So now I should have one line that says here's new line, one line that says done. If I look at dummy.txt, there we go. Here's a new line. Done. And I can make this a little, I can make this a little bit better here so we don't get this extra line here. Let me see if I can remember including a conditional into a list comprehension just right off the top of my head. If I dot index or rather file data dot index I not file data dot length minus 1. And I think I might have to include an else I. Index yeah, I put my else in there. Let's try to try and maybe not equals instead of yeah, okay, not equals instead of not there changes the game. That's what we want. And so here's a line, here's another line, here's a third line. D. Ooh. List object. That's what happens when you write too many. That's what happens when you write too many programming languages in a semester. Len file data, not .len. But that also shows you that, hey, you know, we got interrupted here. And what happens when we get interrupted. So let's paste our data back in, because we lost all our data. And let's go again. We'll talk about how we can fix that. Right? Because when we open it in write mode, it takes all that data out of there, puts it into volatile memory. But we'll talk about how we can fix that here in just a moment, and then we'll wrap up. So we're in our line. Here's a line. Here's another line. Here's a third line. And D for done. And now when we look at dummy.txt, we see it has our lines here. There's no extra last line because of our fancy list comprehension that we wrote here, to where it would put an escape new line after each of the items in our list, but not after the last one. And now that's stored forever. So when we run our program again, this text will already be in it. So we can add more to it if we wanted to do that. Now there's one thing that we closed our file here. And so something that we need to do is we actually need to tell our program when to kind of do things. All right, and so we can do that with try and finally block. Because if something happens while my code is executing, what could happen is my file could get left open. Right? And if my file gets left open, it can cause a memory leak, it can cause some problems, right? So what I want to do here is I want to put basically all of this behind a try block, which is just simply the keyword try. So it's going to try to do all this. I'm going to take everything and tab it over once more, because adding that try block impacted my tab. And then I'm going to add a finally block here before I close my file, which I haven't done here yet. Finally, f.close. Right, and so now that we have a program that we know works, and we can do that here as well, right? We'll put this top part in a try block. Tab that over, tab that over, tab that over, tab that over, tab that over. Put our close behind a finally block, and tab that over. And we end up with a program that can continue to run. So let's convert this for a second. So it's something that is besides just dummy text. Let's do a grocery list. Right, so let's start out with a few items here. Maybe like apples, bananas, pears. And let's add a few items to our grocery list here. Because in essence, that's something that we've done here, right? Like we don't have a fully fledged one quite yet, because we don't really have the ability to delete from our file yet based on what we've done today. We'll get more into that kind of stuff next week, as we also work with CSVs a little bit. But let's run this and see what we can do, right? So we know we have apples, bananas, and pears in our list. Well, so let's add grapes. Let's add chicken. Let's add bread. And let's hit D for done. And so now it's in our list, right? If we go to our dummy.txt, all of that data that we have so far is in our list. We can work to add more to it, right? Like, oh, I remembered some more stuff that I want to add to it. Let me go back in there and add tomatoes. Let me add salad dressing. Let me add hot sauce. I don't know. Let's just throw a few things in there. And now I'm done. Okay, well, I got persistent storage of all of that. Right, it's in there. It's in my program. I can close my program out. I can open Replit back up. I can navigate to that REPL in my REPLs. And all that text is still there. Right? It's still stored in my program. So there's all sorts of different stuff that we can do with this. I think that's a good introduction to this for us for today. So this is where we'll go ahead and stop. We will have a live class next week, even though it is spring break. Again, it'll be pre-recorded. It'll be recorded, so you don't have to attend live if you are unable. But with that being said, that's all. We'll take any questions. If anybody who's here with me live has any, otherwise we'll start wrapping up here and being done for today. There's a lot, there's a lot that's kind of going on here with files, but we can see here that it's more of an order of operations thing than anything else. Just making sure that we're doing the right things at the right time. Otherwise, it's all stuff that we've talked about previously when it comes to dealing with things in volatile memory, dealing with things in lists and things of that nature. When is module 9 due? You know what? Let me verify everything. Because I didn't look before we started, so I assumed that it was due the week after. I assumed that it was due the 20th, but I could have been wrong about that. Let me check. We might be in better or maybe even worse shape than I realized. Normally I check, but I didn't check today. So let's look. Ah, It says the 13th, but you don't need 2 weeks for the last module. I'd rather you all have 2 weeks for this module, so I'm going to adjust that right now. That's going to be the 20th, and this is going to be and we'll start module 10 on the 21st. Not sure what I was thinking there. Because we don't need 2 weeks for the algorithm analysis module. That can be done in one. Yeah, so that's updated in the course schedule, and I'll put that out with the announcement. That was an oversight. So yeah, 20th now. Yeah, we'll talk more about this next week. Any other questions? Now that we have that thankfully cleared up. All right. We will be talking about this more next week. So if you think of any questions between now and then, send them to me. Maybe we can include it in the live stream. We'll go ahead and stop here for today. The goal for next week will be to get into CSVs a little bit and do a full-fledged program where we're using persistent memory, reading and writing from a file. So that's where we'll stop for today. Thank you all for watching. We'll see you next time.